The modern and most preferred Cisco iOS switching process that's in use on iOS equipment is called Cisco Express Forwarding, or CEF. Most of our modern iOS devices use CEF as the default method. CEF stores information in a route cache for optimized lookup and more efficient packet handling. Some of the benefits of CEF include improved performance. This is much less CPU intensive than older methods, meaning that more processing power can be dedicated to other layer 3 services, things like encryption and quality of service. Also, there's more scalability through a mode called distributed CEF or DCEF. When distributed CEF is enabled, each line card maintains an identical copy of the routing table, and the line card is simply the hardware module that provides the network interfaces. Allow this router, I can use the command show IP CEF. I've got a fairly simple topology here, but there are some things I'd like to point out. We can see that listed is the next hop address, as well as the associated outgoing interface that's going to be used for that next hop address. We also see that some of these networks are listed as being attached. For example, the 10.1.1.0/24 network, that's listed as attached. This means that the 10.1.1.0 network in this case is directly attached to the gig 0/1 interface. We see that's listed as the outgoing interface. Also note the next hop assignment receive. Some of these are listed as receive. For example, 198.51.100.1/32. So this is a specific IP address because we see a 32-bit mask, and this is an IP address on one of the router's interfaces, specifically on gig 0/2. So traffic destined for the router itself at this IP address is going to use this interface, and it's going to be identified with that receive label. Let me break out of this command output, and if we want to see the adjacency table, we can say show adjacency, and I'll say detail to do that. Now this is going to contain information about how to reach a specific adjacency or a specific device that's directly connected to the router. And here you can see some of those specific networks that are reachable by going out of a particular interface. We see the 198.51.100.2. We see .6. And up here we see 10.1.1.2. So we see all of those listed. And underneath the interface listing, we see those are on gig 1, 2, and 3. And so these are all of our adjacencies that are found on this specific device. One more thing to mention when using CEF is something called punting. So if a packet can't be processed by CEF for some reason, it is punted to the next fastest switching method. And that preferred order in iOS would first be distributed CEF that we mentioned earlier, then normal CEF, and then fast switching, and finally process switching is the last resort. Now, some of the things that might cause a punt condition would include maybe the CEF lookup process fails. Maybe it can't find a valid entry in the forwarding information base. Or maybe there's a particular layer 2 encapsulation that's not supported by CEF. And also, very commonly, you'll see fragmented packets in a network. Those are always going to be processed by the router, so they'll be punted down to the process switching mechanism. And those are just to name a few instances where we would see punting happen. So that's an overview of Cisco Express Forwarding and how CEF uses forwarding information bases and adjacency tables to more efficiently control our traffic.